In this lesson, I'm going to show you what the project structure and architecture looks like, and we are going to end up with a moving star background. It will simulate as if we're traveling through space. So we have our main file, index.html. It includes state, game state, and main.js. Main.js is the entry point of our application. We are using in this project the namespace pattern. In other projects, we've created different variables on the global scope. We've created a variable called game, and then variables for each one of our states. In this project, we'll take a different approach. We'll create a single variable called spacehipster, and all of the other objects, the game, the different states, the prefabs that we'll add later and explain later, are all going to go inside of spacehipster. It is a good practice to clean the global scope as clean as possible, to keep it as clean as possible. So that's what we're doing. By doing this, all I'm saying is create a variable called spacehipster. If that already exists, then use it. If that doesn't exist, then let's start with a new object. I'm going to put this at the beginning of all of my files. So in all my files, we will be using the same spacehipster object. Okay, we start by creating a new phaser game, and we set the dimensions to 100%. In here, you can either enter numbers or you can enter percentages. It will be a percentage of the screen. We want our stars background to cover all of the screen, no matter the size of the device, so we enter 100%. Then we add our state and see how our state is inside of spacehipster 2. So you'll be seeing this a lot. Spacehipster dot the object, and we start our state. Now, what does our state look like? We begin by using the namespace pattern. We have an init function where we need to set some basic resolution options, and I've already added the code to load all of the images and sprite sheets with their corresponding dimensions. You can also look at them. You can look at them right here, which is quite cool, being able to look at them directly from the code editor. Okay, so what we'll do now is set our preferred scaling mode, and we want to use all of the area, and we don't want any distortion of pixels. So we will use the show all scale mode. Scale mode equals phaser dot scale manager dot show all. Then we also want to have our physics system initiated. Start system, and that is phaser dot physics dot arcade. Great. So now we have our physics system initiated. Now see how every time I save, this automatically reloads, so we don't have to manually be reloading this all the time. If you don't want your app to be reloaded all the time, you can go to Run My App, and then running in emulator, there is an option that says Restart App After Save. So if you click No in that, it will not reload every time that you save your code. So now that we've set up some basic configuration, I'm also going to set define some constants that we'll use later in the game. Player speed and the bullet speed for the player and the enemy bullets. I'm going to set this to -1000 because the bullets go upwards from the player. Now on create, I want to end this by having a stars background, and our stars image space.png is just a 40 by 40 small image. And I want that repeated everywhere. I want that repeated over and over. So we can do that by creating what's called a tile sprite, which is a sprite that repeats itself within an area that you specify. You specify the coordinates of this rectangle, and the tile sprite will repeat itself within that area. How do we create one? This.add.tile sprite. The beginning of the rectangle will be the top left. So that's 0 and 0. And then it will be as large as the game itself. the dimension of the game is this game.world.width. That is the dimension of the game world, and since we are setting the game to occupy all of the screen, it will be the same as that of the screen. This, and then the height, this .game.world.height. And now what is the key of this sprite is space. We preloaded in here. This should show our start background, as you can see. And I want to make this background to be moving. So tile sprites have this method called auto scroll, which you use to have a moving background. I don't want it to move on X. I just want it to move on Y, and I'll give it a speed of 30. So now you can see that it's actually moving, that we have a moving background that simulates that we are traveling in space. So to summarize, in this project, we are using the namespace pattern. So we put all of the objects inside of an object called space hipster, and we do that so that we don't pollute the global scope of our application. It's just a good practice. The dimension of the game area is going to be the 100%, and we are specifying that there's not going to be any particular type of distortion of the scale, and we're going to use all the area that we can. We initiate our physics engine, and we set some constants, and then we created a tile sprite, which is a sprite that repeats itself over a rectangle. You specify the coordinates of that rectangle and obviously the key of the sprite, because otherwise it's not going to know which sprite you need to use. And we auto scroll this background by using the auto scroll method, which can do auto scrolling in both X and Y coordinates. If you enter a negative value, it will move in the other direction.